Hi everybody, Module 4, Lesson 4, percent increase and decrease. Students will be able to solve problems involving percent. So the opening exercise, we're going to kind of fly through this a little bit. Actually, we're going to skip it somewhat. What I want you to notice is that Cassandra likes jewelry, and she currently has 5 rings in her jewelry box. And then we're going to come down to example 1. Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her ring collection? Percent increase. That is cluing me into which of the formulas I'm going to use. So we have a new formula today. It is change equals percent of original. This works the same way as the is equals percent of, and part equals percent whole. But when we're talking about percent increase or percent decrease, we're using change equals percent of original. I know we have a lot of scrolling. Sorry about that. So we know that Cassandra is going to get a new ring. Means the change equals percent of original. She's getting a new ring. So that means it's changing by 1 ring. And that equals X percent, because it wants to know the percent increase. What was the original number of rings she had? If you read up at the top, I highlighted it. She currently has her original amount, her starting amount is 5 rings. Right, so there's our equation. We're going to solve it just like we've been solving all the other ones. Multiply by the reciprocal. And I type into my calculator 1 divide 5 times 1, and that works out to be 0.2. So what was the percent increase? She has a 20% increase. And I do need you to write the word increase or the word decrease depending on what is happening. So let's do a few more problems like this. John increased his trading card collection by 5 cards. He originally had 15 cards. What is the percent increase? It's saying to use the equation quantity equals percent times whole to arrive at your answer. We know, and then we'll cross out the rest, we know that that is the same as change equals percent of original. So how much did John's collection change by? It increased by 5 cards. It wants to know the percent increase. So our percent is X. And he originally, oh, there's the word, originally had 15 cards. So we're going to pause the video and you're going to solve it. I'm sure you can do that by now. Give it a try. How did you do? So this one was a repeating decimal. So make sure that you move the decimal place 2 places when you change it to a percent. And it's still repeating, so we have the line over the 3 that's in the decimal place. Please find where it talks about Ken. Ken said that he is going to reduce the number of calories that he eats during the day. Ken's trainer asked him to start off small and reduce the number of calories by no more than 7%. Ken estimated and consumed 2,200 calories per day instead of his normal 2,500 calories per day until the next time he visited with the trainer. Did Ken reduce his calorie intake by no more than 7%? Justify your answer. So there's a few ways to do this problem. I'm going to approach it with the same formula that we've been talking about today. Change equals percent of original. How much did his calorie consumption change by? Well, his calorie consumption was 2,500, and now it's 2,200. So that's a 300 calorie change. And that equals, we don't know the percent, and the original. Which one is the original? It's a 2,500, his normal. Not the new, but the original. All right, so these numbers might be a little larger, but it's still done the same way. We found what our change is. We don't know our percent, so it's x. We determine what is our original. Solve the equation. Go ahead and pause it, give it a try. Did you come up with a 12% decrease? And did we answer the question? It says, did Ken reduce his calorie intake by no more than 7%? So Ken reduced more than 7%. And we justified our answer by showing the work. All right, let's find example 3. Go ahead and try problem A on your own. Pause the video, give it a try. Did you come up with a 25% increase? If not, pause the video and take a look at my work and try to figure out why I did what I did. All right. Example 4. The population of cats in a rural neighborhood has declined in the past year by roughly 30%. Residents hypothesize that this is due to wild coyotes preying on the cats. The current cat population in the neighborhood is estimated to be 12. Approximately how many cats were there originally? Oh, I know originally is going to be my X value. It declined by roughly 30%. So that means now 70% of original. Think about that. If it's down 30%, that means it's 100% would be it's the same as what it originally was, but it's down 30%. So that means 70%. So change equals percent of original. The change, how much did it change by? The current population is estimated to be 12. So how much did it change by? We're not using the change formula, are we? We're actually going to say 12 is 70% of the original. Think about that. We don't know how much it changed, and we're not using the 30%, but we are recognizing that 12 is a smaller part of what it originally was. Right, so 12 equals 0.70 x. 1 over 0.70, 1 over 0.70, and, oh, this is a weird number in the calculator, isn't it? I'm going to round to 17.14 equals x. So about 17%, sorry, it's not a percent, about 17 cats originally. And do you ever really know how many cats are in the neighborhood? How big is the neighborhood? How many cats come and go? And especially those of us that live out in the woods, we have extra cats, don't we? News math score. I think we'll stop here. So we are obviously going to practice more in class. Replay the video if you need to. Be prepared with questions. You know I'm going to ask. I'm going to show these notes page and ask who has questions. Thoughts, how does it relate to other things? Share your thinking with us in class or your questions. Bye.